Okay, so we have the following problem. A factory can make jeans or trousers. Each pair of jeans takes 3 hours to make. Trousers take 2 hours each. There are 90 working hours available per day. Each pair of jeans costs €10 to produce and each pair of trousers €15. There is a budget of €600 per day available. A pair of jeans get a profit of €8 and trousers get €6. How many of each to maximize profit? So we want to maximize the profit making X number of jeans and Y number of trousers. So the number of jeans we're going to call them X and the number of trousers we're going to call them Y. So we get that we get 3 hours to make jean, each one, and then 2 hours to make each trouser. So which means is that if the numbers of hours 3 multiplied by X, which is the number of jeans, plus the number of hours, so it's 2 hours to make each trouser, by the number of trousers we're going to make has to be less or equal than 90 working hours. That's the maximum. So as maximum it has to be 90. Okay, so we leave it there. Okay, so now we have now one equation, right? But then we need another one. So basically the other one says that each pair of jeans costs €10 to produce. Okay, I'm going to highlight it here. Each pair of jeans costs €10 to produce and each pair of trousers costs €15. So what we know is that per each number of jeans is gonna cost us €10. So it's gonna be 10x because it's €10 by the number of jeans plus €15 by the number of trousers. Y has to be less or equal than €600, which is our budget a day. So now we have two equations. So what do we do now? Well, we can simplify this equation here. Oh no, actually we can't. So we're just gonna leave it like this. Now we're gonna have to graph our equation. We're gonna actually graph the two equations. Okay, there's gonna be our X on Y, and then we're gonna split it up. Okay, so in this one we're gonna use ret. Okay, so we're gonna use ret for that one. Okay, I'll point it out. So we have the 3x plus 2y is less or equal than 90. So when we say that x is equal to 0, when x is equal to 0, then y, we're gonna get that y is gonna be where we have 2y is 90, so y is equal to 45. So now we have the y is equal to 45. Okay, I'll get rid of this so we're not messy. And then we're going to use the green color for the other equation. Okay, and I'll point it out here as well. So we have 10x plus 15y less or equal than 600. Okay, so as you know, I'm using equals now because we can't use the other ones, okay? Because we're trying to find points on the graph, okay? So now we have 1 point, oh, I forgot to get to the point. So this point is going to be 0, 45. And this one here is going to be, and then the second point we're going to get if y is equal to 0, x is equal to 90 over 3 is 30, okay? So we have the point 0. Now we have the point 30, 0. Okay, now let's go back to this equation. So when x is equal to 0, y is gonna be 15, it's 4, it's 40, y is equal to 40. So we have the point 0, 40. Then when y is equal to 0, x is equal to 60. So we have the point 60, 0. So what we're going to do, we're going to split up the graph into, let me think, we're going to split up the graph into 15. So it's going to be 15, 30, 45, 60. 15, 30, 45. Okay, so we're going to use the red one for the first equation. So we have the point 0, 45, so it's 0, on the x, 45, and then 30, 0. So we have now one line done. Okay, and I'll try to expand it a little bit, okay? It's not the best accurate method, but it does the job, which is what we're looking for. And then with the green one, we're going to do, we have the point 0, 40. So we have 0, 40. So I'll say this is, this point here is, okay, so it'll be somewhere around here. So let's say here. And 60, 0. This one here. So we're going to pull it up together. And here. So now we got this point here. This point is going to be the maximum point of which we can get number of y and number of x. So if we bring this point here down, okay, I'm going to use the orange color. Okay, and if we bring it here, we're going to get 30, that's going to be 38, and this one is going to be more or less 1, 2, 3. This is going to be 5, more or less. This is why it's not the best accurate method to do it. So we get the y value is going to be 38, and the x value is going to be 5. So we said the x is the number of genes, so we can make 38 genes and 5 trousers. And that is going to be our answer. How do we check it? Okay, basically to check it, what we do is we're going to check the data we have. So we make 38, we're going to first check the hours, okay? So genes take, as it says on the top, it takes 3 hours, so 38 by 3 plus 5 trousers by 2 is equal to, that is 10, okay. Let me just get the calculator. So we have 38 by 3 plus 10 is going to be 124, and then that's going to be hours, and we're given that, oh no, okay, so what I did wrong is that this is not jeans, this is trousers. Okay, so this is going to be trousers, and this is going to be jeans. Okay, I got it wrong. This is why you have to check it, okay, because it happened to me, I fucked up. So basically we have 38 by 2 hours it takes each trouser to make, plus 5 multiplied by 3 hours it takes each jean. It's going to be 38 by 2 plus 15. Okay, it's going to be 90 hours. Okay, and then we have 38 jeans by the money takes each trouser, 38 trousers, and and the cost of each trouser is 15 euro plus 5, and the cost is 10 euro. It's going to be 38 by 15 plus 50 is going to be 620 euro. What happened? We had a profit of 600 euro. So what I did is that, because this is a graph and it's not really accurate, maybe that 5 might be 4 genes instead of 5 genes, and then here this might be 4 instead of maybe 4 point something, and this here might be 37.1 or 36, but because it's not really accurate, we can't really rely on the graph. But this is the way to do it with the graph, okay?